Hello students, in this program we are going to add two matrices using a function. The purpose is this. The purpose is as shown. Write a program to add two matrices which are equal size. Remember, as we know from mathematics, it is necessary for two matrices to be equal size. That means number of rows and number of columns must be same in the two matrices if we want to add them. Now look at an example. We have a matrix A and another matrix B, both of which are size 3 by 5. That means there are 3 rows in both A and B and 5 columns in both of them. So you can see that A has row number row 0, row 1, row 2, and this is row 0, row 1 and row 2 of matrix B. Okay, similarly there will be columns in both the matrices. This will be the first column of matrix A, this is the first column of matrix B, this is the second column of matrix B, and so on. So we want to add them. So when we add two matrices, then the procedure of adding two matrices is that the numbers at corresponding locations in the two matrices are added. So for example, if we consider 5 of matrix A, then it will be added with 20 of matrix B, because both of them happen to be at row number 1 and column number 5 in the two matrices. So they are at the same locations in the two matrices. So these two will be added, and when they are added we get 25, which is put at the same location in the resultant matrix C. See here, and 25 is put at the same location as 5 and 20 are in A and B respectively. Okay, so that is what we want to do. Similarly, all the other items are added, like 15 is added with 30, which produces 45, which is placed as the last element in matrix C, in the last column of third row. So this is the procedure of adding two matrices. Now before we look at the program, we want to look at some points. So first thing is, how do we represent a matrix? Okay, so as should be clear by now, we are representing matrices using nested lists. Okay, when we have lists as elements of a list, then we say it is a nested list. Okay, a list having list as its element is a nested list. Then each inner list of a nested list represents a row of matrix, and items at one index in all the inner lists represents a column of the matrix. Okay, consider list A. It represents the following matrix. So the list A, which we see here, this list A, this list A, which we just saw, represents a matrix which is depicted here. So this is the matrix that is represented by list A. See, these are the 3 rows of the list. Now these 3 rows are can be accessed with indexes on list A. Okay, the first row will be at index 0, second row at index 1, and the third row at index 2. Similarly, all the items at one particular index in all the inner lists make up a column. For example, if we say index 3, then the items 4, 9 and 14, they create a column of the matrix. Okay, similarly at indexes 0, 1, 2, 3 and 4 we have different columns. So this is how we represent a matrix in a Python program using nested lists. Now, as we are using a nested list to represent a matrix, we need two indexes to access. Slide we need two indexes to access a number in the matrix. Okay, the first index will tell us the row or the inner list. So for example, this index 1 tells us that we are talking about this row. Okay, and the second index tells us the column of the number. That means the index of the number inside the inner list. So if we talk about this 9, it has the index 3. Okay, you can see it from here, it is at index 3. So we need two indexes. First index 1 will tell us which row we are talking about, and the second index 3 which will represent that we are at index 3 in the row 1, which means we are talking about 9. So to access any number, we need two indexes. See, this we have just seen that a square bracket 1 square bracket 3. So two indexes 1 and 3 represent 9, refer to 9 in list A. Okay, similarly we have list B. So if we consider the same two indexes 1 and 3, then B square bracket 1 square bracket 3 represents the item at column 3 in row 1. Okay, so row 1 column 3, that means we are talking about item 24, which is 24. So B square bracket 1 square bracket 3 represents 24. So any number in the list in the matrices A and B can be accessed with the two indexes. So suppose you want to refer to 16, then you will write B. The first index is the row number, so it will be 0. Second index has to be the column number inside the inner list, inside the row. So again it will be 0. So B00 represents 16. So, and if you say you were to access this item 30, then you will write name of the matrix B followed by index of the row. So row is the row index is 2, so we will write 2, and the column index is 4 because it is the last column. Last column has index 4. So B square bracket 2 square bracket 4 refers to 30. So this is how two indexes work to refer to an element in the matrix. Then how do we add these two matrices is discussed now. We will first create an empty list C. Okay, we will start with an empty list C. We will append list to C. Okay, we will append list to C obtained by adding inner lists which are actually rows of matrices from A and B at the same index. Okay, so the empty list C will get its rows as the result of the addition of rows from A and B at the same index. For example, row 0 of A added to row 0 of B produces the row 0 of matrix C, which is shown in red color below. See, this is the row 0 of matrix A, and this is the row 0 of matrix B. When these two will be added, we will get this row 0 of matrix C. This is how matrix addition will be performed. Similarly, when row 1 of matrix A will be added to row 2 of matrix B, we will obtain the second row of matrix C. Okay, similarly the third row will be obtained. So why we are talking about adding the two rows of matrices is that because we already have a function which can add two lists. Okay, we have a function which was written in a previous program which adds these two lists of the same size and produces a list as a result. So that result may be appended to this empty list C one by one. So we will get the resultant matrix. In this way we can add the complete matrices A and B. All the rows are added one by one. Now, uh, as said, we will use a function add to list, which we discussed in an earlier program. Okay. Now the function add to list takes two arguments, x and y. Two arguments. X and y are simply equal size lists of numbers. Okay. And what this function does is to add the numbers from these two lists from same indexes. Okay, all the indexes are processed and the numbers from the a particular index from the two lists are taken and added and put in the resulting list at the same index. Right. Now we look at the program itself. This is the function which we will be using to add to lists. Okay. It has already been discussed. What this function does is to create an empty list z, and for all the indexes in the list x and y, which is obtained by range 0, length, x, because this will supply values 0, 1, 2 up to length -1 to this loop variable I. So we'll get all the indexes of a and b in this loop variable I, and what we do is to first we find the sum of the items at index I in x and y by writing x square bracket I plus y square bracket I, and then the result is appended to this list z. Okay, so for every index this is repeated. So for index 0 to length -1, z gets items appended to it, which are the result of the additions of items in x and y at the same index. After this loop is completed, the resulting matrix resulting list z is ready and it is returned. Now the main programs will start. In the main program we have the same two matrices A and B, and we the same logic applies. We are again creating an empty list first C. Okay, this C will be the resultant matrix which is addition of A and B. Okay, it will have all the rows which will be obtained by adding the corresponding rows of A and B. Now how we do it? See, we again run a loop for I in range 0 to length A. Now what does this loop signify? This loop variable I gets the value 0, 1 and 2. Why? Because length of A or length of B, which both are same, represents how many items are there in A or B. Okay, so when we say length of B or length of A, we get the number of inner lists inside it, which is 3. Okay, it has nothing to do how many elements are there in the inner list. Okay, the items of this list B are these lists only. Okay, so we are concerned about these lists. Okay, and there are 3 inner lists, so the length of B or length of A will be 3. Okay, so the loop variable I will be getting the values 0, 1 and 2. Okay, so by this loop we will be able to process the rows directly from A and B. So now what we do is to call this function add to list. Okay, the function which we just discussed, add to list, and we will apply it to the row at index I in matrix A and the row at index I in matrix B. That means first of all the row at index 0 in A and B will be added, and the result will be appended to the matrix C. Okay, the result is a list, as we know, which will actually become a row in the resulting matrix C. So for index 0, the first rows from the two matrices A and B will be added. For index 1, the second rows from the matrices A and B will be added, and the result will again be appended to C. And finally, with index 2, the last rows from A and B will be added by this function add to list, and the result will be a row which will be appended to matrix C. So this is how our resulting matrix C will be calculated. Now what remains after this loop is just to present the output to the user. That we do using two print statements, and the first we just print a message, the sum of the two matrices, and then we print the matrix C. That's all in this program. Thank you.